Hello, everyone. Our experiment is based on scalloped hammerheads and the effects that bycatch has on them.
My name's Lee Friedman.
I'm Lucas Scalloped.
I'm Jordan Pendarvis.
And I'm Valerie Spradlin.
I'll be going over the background information, which led to our research proposal. Scalloped hammerhead sharks have been officially labeled endangered by the US government since 2011. However, shark fisheries still target this species for ingredients to shark fin soup, a delicacy in many Asian countries. Hammerheads also are often caught as bycatch. Bycatch is when fishermen accidentally catch other species other than the target species. In both catch and release fishing and release from bycatch, these hammerhead sharks experience a high mortality rate from increased stress. Research has yet to be done on how the stress causes the sharks to die. This high mortality rate puts increased strain on the scalloped hammerhead species as more sharks perish beyond the limits set by the shark fisheries. When fishermen accidentally catch sharks, the sharks could undergo a prolonged struggle, fighting whatever has caught them. This puts the shark's muscles under an increased strain. Sharks' muscles are made for quick movements, like a rapid burst towards prey. Basically, these muscles are used for sprinting, not marathoning. Being bycatch forces the shark to use its muscles for an extended duration of time beyond the shark's limitations. This could lead to the shark damaging or weakening its muscles. Scientists have found that scalloped hammerheads demonstrate sex segregation. Males tend to stay within shallower waters, while the females tend to go into deeper waters. These deeper waters provide more energy-rich food for the females. As adults, these animals are highly migratory. They tend to live in schools above a seamount. At night, they independently venture out into the ocean for rich feeding grounds. Then they return to their home seamount. This schooling behavior is most often seen with females. Juveniles demonstrate a predictable migratory pattern. After they are born, they will spend 3 to 4 months in a shallow bay, such as Kanaohe Bay. In Hawaii, females will tend to leave the nursery a couple of months prior to the males. Scientists believe this helps speed the development and maturity of females. For both sexes, the deeper water allows the sharks to mature into migratory adults.
So now the question and hypothesis of our research proposal. So our research question is, how does being caught as bycatch affect the behavior of these hammerhead sharks, and more specifically, their migration patterns? So we hypothesize that the constant catch and release of hammerhead sharks will result in a negative impact on the fitness and survival of the species due to the experience of being caught, causing changes in the migrational behaviors of these hammerhead sharks.
So for our experiment, we're going to divide our team into 2 groups. One will be simulating bycatch and the other one the control. We'll randomly select an area off of the coast of Hawaii each day for a period of 3 weeks. We'd begin our study in May, and we would begin our study in May when the juveniles are most prevalent in the bay. Our teams would go out on their own vessels for 3 hours each day for a period of 3 weeks, or until each group has caught 25 sharks. They would return to the shore after 3 hours, regardless of what was caught. The group simulating bycatch would use fishing reels and actively reel in the fish to achieve the same muscle usage as catch and release fishing or bycatch. The control group would just use their scuba gear to tag and take samples of the sharks while they're still underwater. This would minimize stress to the animal. Any tissue samples that would be taken would be put in test tubes and be later analyzed for biological signs of stress. And for each shark, we would record its measurement, sex, and location where it was tagged. Specifically, we would be targeting juveniles within the nursery.
You're muted. You're muted. You're muted.
In our experiment, our independent variable will be the catching condition of simulated bycatch. Our control variables will be water temperature, geographic area, and age of juvenile sharks. And our dependent variable will be the migration pattern abnormalities as demonstrated by the distance they travel from the nursery ground. Here are some of our predictions for our experiment. While the migration of sharks are variable, there are certain patterns that emerge. For example, males and females tend to live at different areas, and females tend to return to shallow water during gestation. As bycatch, a hammerhead shark's muscles undergo strain due to participating in an abnormal activity. This could impede the shark from following its normal migratory patterns. Therefore, we predict that the experimental groups will demonstrate alternative migratory patterns than the control group. Our group that experiences bycatch will exemplify muscle deterioration and stress levels evident by the increased pH, blood lactate, and glucose levels.
So now here are the expected results of our experiment. So from the satellite, we can see how far the juveniles traveled from the bay. Under the control condition, the females should leave the bay for deeper waters earlier than males, and the experimental group may never even leave the bay. The data in the graph is the distance away from the bay that the sharks traveled. So in the graph, we could see that there's a big difference between the control group and how far they traveled and the experimental group, and they barely even traveled at all. So that just shows that the bycatch is negatively affecting the migration patterns of those that are caught.
I'll be going over the rationale of our budget. The price of tickets includes the flight to and from Hawaii. To not risk any equipment loss on the flight, we'll be renting some necessary equipment on the island. The lodgings are for a 10-person condo for 3 weeks. We will be needing 2 research vessels. So this price encompasses renting both vessels for 3 hours each day for 21 days at a price of $366 per hour. The price of chum and bait encompasses 700 pounds of bait. Dividing this between 2 vessels for 21 days gives each boat 16.5 pounds of bait over the 3-hour boating period. The fishing lines, hooks, and reels are of a strength to be able to withstand juvenile sharks. This equipment is for the experimental group only. We will be renting the scuba gear to ensure that we have the available equipment. We do not want our equipment to be lost during travel, which would set back our research. Only the control group would need this scuba gear, and this cost encompasses 5 sets of gear for 21 days. The average price of a satellite tag is $2,700, and at the very least, we would need 50 tags. We would take samples from each shark and test physiological signs of stress, like pH and blood lactate. This would require at least 50 test tubes and 50 blood analysis tests. Each blood analysis test costs $80. There are subscription fees as well to be able to track the sharks using the satellites. The price for the subscription is $100 per month per shark. For 18 months with 50 sharks, it will cost $90,000. Lastly, we'll be primarily using grad students and undergraduates as our research assistants. We have estimated to need 6 additional team members so that each vessel will have 5 researchers. The salary estimate uses an average yearly salary of $40,000 and extended for a period of 18 months. Using the latest data from the Bureau of Labor Statistics, employee benefits are usually 31% of total compensation. Therefore, we multiplied our yearly salary by 31% to yield employee benefits. The office space is in Gainesville and is proportionate to the size of our research team. The estimate for utilities comes from the average cost of utilities per square foot in Gainesville. This concludes our presentation, and we hope that you decide to fund our necessary research for the scalloped hammerhead sharks.